Where microphone?
Hello?
Is that working?
Okay, so I'll leave my computer. Oh.
Thank you.
Okay, yeah. Just side by side.
Yeah. Right. Yeah, thank you. Hopefully that's it. But yeah, as I was saying, so this project is part of a kind of wider group. So we also have James Page here at the BSc who's working on the inland waterways to add that to the network. And also at ECAC with Alexandra Lavarda in Tarragona, looking at the kind of archaeobotanical remains. So that's some of the data we're going to use to see how that moves across this network that we're building. So we're not just building this network for the sake of it. We're going to look at how things move across it and how people interact. Okay, so the kind of core outputs of the project is methodological focus. So again, today I'll talk quite a lot about the methodology and try and show like how this new methodology can help in various things. So it gives us a lot of data. So one of the first outputs is these raster-based outputs, and that's what I'll talk about today. It kind of gives quantitative data so we can look at things like urbanism and like seasonal changes. But we'll also move that into kind of a vector-based thing and look at a universal network. So we have all these different modes of moving between the nodes, which I'll explain in more detail. So yeah, a little bit about the Roman Empire and like the data that I'm using and that I'll be talking about today. So as I kind of briefly mentioned, this methodology is applicable kind of anywhere and at any time. I'm using like the Roman Empire as a case study, kind of. I mean, I'm a Roman archaeologist, so that's one of the main reasons. But also because there's a relative abundance of data that we can use from the Roman Empire. So we have a lot of sites that we have relatively good information about, and we also have routes that we can compare it to. But again, this methodology, so long as you have a couple of sites, you can apply it anywhere. Um, and yeah, so today especially we'll be talking about urbanism. So using this database of urban centers um, to it kind of we use these node sites to construct the model, but mostly we're using the urban centers to get the data and kind of understand what the model's actually showing us, which again I'll explain in more detail. But we also have roads that have been, or routes that have been reconstructed using archaeological data for the Roman Empire. So this is just one example. And you can kind of see, and I'll talk in more detail about that, there's some gaps like in this. There's some dead ends and some cities that aren't connected. And that's the kind of inherent nature of archaeological data is incomplete. So, if we're building, reconstructing routes based on this archaeological data, we can get good detail where we have evidence, but where we don't have evidence, we have these gaps. So again, this methodology is a way of kind of filling in these gaps and expanding on that. So yeah, the methodology is multi-temporal, multi-factor, and I'll talk about both of those things. So most cost surfaces, and this is what we have here, a cost surface for anyone who's not sure. It's basically a grid of cells or pixels that each has a number, like a value. In this case, it's a cost, and that cost can be time or money or energy or whatever else. And normally these cost surfaces are constructed just using one variable, slope. It's normally terrain based or topographical. So, if it's a steep slope, it costs more. It takes more time, it takes more energy to go up it than with a flat surface. So that's normally how cost surfaces are reconstructed. Where we have this methodology where we add numerous different factors. So it's multi-factor. So we start with slope as most of them, and then we have these additional factors that multiply the cost. So we have a cost based on slope, and then things like snow, the cold, like the temperature, and especially wind chill increases that cost. And we have loose sand, lack of water, and elevation. So these are the kind of core factors that we're adding into this cost surface. And this was developed by Hector, which I have the link to his GitHub, and for the applying this cost to the Silk Road. So again, this is me looking at applying it in different scenarios. It's not just the Roman Empire that we can use it for. So we construct these cost surfaces in Google Earth Engine, like all the data's open access. Anyone who can get a Google account can make these cost surfaces. The resolution of it is based on the DM, so like the elevation model, which is from this source here, and I think in 30-meter resolution, the highest resolution. Most of the examples I'll be using here are in like 100-meter or 93, I think it is. But when on this scale, the difference between 30 and 100-meter resolution is insignificant, but the kind of computing power we need to up that resolution exponentially increases. So most of these examples I'll show you are 100-meter resolution. And that's the core. So this slope is derived from the elevation. Then we have these different, again, open access sources for the other factors to get the data. And for loose sand, Hector developed an algorithm to detect the presence of loose sand. And then we have the factors that add on all these different costs. And we have an example here. If you look at the differences, it's quite subtle. We have here the cost surface for August, and this is without the loose sand cost. But if you look at this one, that's all the factors. So you can see most of the map doesn't really change, but in the south, like these desert areas in North Africa, you can see the cost increases with adding that. And so, that's just the difference of adding these different factors. We get these different parts, different regions are affected in different ways. And we also have the seasonal costs. So again, while most cost surfaces just use one factor, they're also kind of, they don't change with time. It's a flat cost. Where a lot of these factors that we're adding, like the temperature, snow, things like that, these are seasonal. So they change depending on the season. So you can see here, again, this is August with all factors, and then February with all factors. You see the cost changes there. And again, the change is like regional as well. So especially in the north and in the mountains, which like logically makes sense. When we've got snow and we've got cold temperatures, the cost increases, especially when you're in an already kind of cold, high altitude area. So again, before we even start making the model, we can already see that having these multi-factor and multi-temporal, or this multi-factor multi-temporal approach to cost surfaces makes a difference. And then once we get these cost surfaces, we build the actual corridors, so actually make this network to understand how things move across. And what we do is we generate corridors between node sites. So I've tested kind of different numbers. I think it's 40 node sites here. And these node sites aren't chosen necessarily because they're particularly important or significant cities or sites. We've tried to cover the kind of entire range of the Roman Empire. So these are all kind of sites along the edge. And then we've included some sites like Rome itself, obviously, to put into as a node. And what we do is we generate corridors only between these sites. So all the other urban centers, I think 1,500 we have in total, aren't actually in the model at all. We can just use them to get quantitative data. So what we do is build a cumulative cost surface. So from each of the node sites. So basically that's we have the cost surface that you saw, and the algorithm just accumulates the cost as you move away from the node site. So this is from Rome, and you can see as you get further away, the cost increases. So it's a fairly simple approach. And so this is run in GraphJS using R cost, which is the night smooth algorithm, which is basically just a more really realistic approach to modeling movement. So you get extra diagonal movement. It's not just moving one cell, north or east. You can have these diagonal directions as well. So we generate these cumulative cost surfaces for every node site. So this one is for Tarraco, so Tarragona. And you see again, like as you move further away, the cost increases. And to get a corridor, we basically just take every pair of these cumulative cost surfaces and average them. And that gives us this. You can see it's an average cost between Tarraco and Rome. And then if we take those and mess around with the visualization a little bit, and normalize them and merge them all together. So this is every pair of sites, every corridor between every pair of sites merged together with minimum cell sets. So it's a fairly simple methodology that gives us quite detailed and impressive output. So basically, we make cumulative cost surfaces for these 40 node sites, generate average every single pair of them, and then normalize them and merge them together. And it gives us this, detailed look of low cost routes across the empire. And again, this just all you need to do this is the cost surface and points. Like this doesn't have to be in the Roman Empire. It can be anywhere else that you have any sites you want to look at. And again, this is just the 40 sites, but it covers the whole empire. And you see different routes between them that start to pop out, even though there's no sites actually built into the model in those areas. So I'll talk a little bit about some of the results we have. So first, just like a kind of visual look at some of these and the differences we can see, and then I'll go into some of the kind of quantitative stuff that we have. So it gives us this broad landscape of low-cost corridors. So again, this raster-based approach where everything, every cell has a value, and the closer the value is to one, or the lower the cost, and the kind of closer you are to one of these natural low-cost corridors. So what we can then do after that is put any sites, and I've done here today, like the urban centers that aren't built in, not these node sites, and you can get a value from where they are, and quantitatively you can see how close and relatively close they are to these natural corridors.
Question.
Yeah.
Is it okay?
Yeah, please.
Would you expect that these kind of intersections would create a city?
It can do. So we can, and that's something we can look at where we have these intersections between all of these. Yeah, so and especially up here, you can see this really clear intersection, and there's like a cluster of the cities there. Some of them no, because some of these are just routes that are crossing. But it's kind of proximity to any of these low cost corridors. But yeah, the intersection we do see, and certainly some of them, like a cluster of sites. Yeah, if anyone has questions, just shout out, please. So yeah, but this like whole kind of landscape that we have changes depending on the season. So again, this is February, and that's in August. And so you can see some of the corridors broadly stay the same, but you can see some change kind of completely. Those things shifting, things moving around. So again, this approach to actually having a temporal cost surface is, I think, much more important for the land than we've really thought about before. Again, just visually, you can see the difference with it. And yeah, so if we kind of take a closer look, so this is in the Alps in August, so the summer months. You can see there's a lot of kind of nice low-cost corridors that go through the Alps, and we have some cities along these corridors that you can see here. So when I say cities, these are like Roman urban centers. They're not giant metropolises all the time, but kind of urban centers. And you can see these along the routes. But then if we switch it to, again, the exact same place, but in February, you see it changes. We still have these corridors, and especially where the cities are, so these are still accessible. But you see the much bigger chunks of it are essentially impassable at this point, or certainly much higher cost. But more than that, we can see like relative costs change. So if we look even away from the mountains down to the coast here, so in February, you see this coastal route is a very clear kind of low-cost corridor, where in August, where it's easier to move through the mountains, relatively, we don't have as clear a corridor down here in the coast. So the actual cost of the coast probably isn't changing that much in this season to season, but the relative cost is changing quite a lot. So when the mountains are less passable, it's relatively less costly to move along these. So again, already just with this one example, you can see how like these corridors shift depending on the seasonal like conditions. And yeah, so from again just a visual analysis, you can see a lot of urban centres lie along these routes. And again, even in the winter conditions where this is less passable, we still have urban centres lying along these routes, which is starting to suggest that there is, a relationship between connectivity, mobility, and urbanism. And I have some fairly ugly graphs here, but bear with me. Um, Essentially, this is showing quantitatively what you can kind of visually look at. That urban centres statistically are on or very close to these natural low-cost corridors. So there is a relationship between like the distribution or between urbanism and this connectivity. And that's the case for every season. And you can see here that February, so the winter months, have a higher overall cost, which again makes sense when we have cold and snow as an additional cost. That makes sense that would increase in winter. But even then, the kind of the low cost corridors that are there in February, the urban centres overwhelmingly lie along or right next to these low cost corridors. So it's something that I think's kind of logical that urban centres are in well connected areas, but we can show it here kind of quantitatively and statistically, and that is the case. And then looking kind of into more detail, trying to compare the size of urban centres and the proximity or the low cost. So I'll say like the local mean cost here is for each individual urban centre, and the lower that local mean cost is, the closer it is to one of these low cost corridors. So you can see here there isn't as clear a relationship. The biggest urban centres, so like Rome down here, you can see does have a very low cost, so it is very close to these corridors. But there isn't as kind of clear a relationship there. And I mean, this is very possibly because this version of the model just now is purely terrestrial. We don't have the maritime stuff yet. So a lot of these big urban centres are coastal like port cities. So once we add in these maritime corridors, we might see there actually is a clearer relationship with the size. But already with this, there seems to be some relationship between again, these low-cost corridors and the civic or economic importance of the cities. So we have just some of the biggest or the most economically important centers in the Roman Empire. So Rome itself, and then we have Carthage, Alexandria. These all have very low costs, so are very close to these routes. And then if we look at some of the different civic groupings, so we have capitals. So obviously Rome, like the capital of the empire, and then provincial capitals or metropolis capitals. These all as groups have much lower costs than other civic group categories. Which again, we need to add maritime stuff and see what that does. but this looks much more like these are along these routes.
You may talk about this later, but I'm wondering how exogenous is the cost of the corridors in the sense that most of the variables are kind of fixed, but there was something like you said the lack of water that could be done or affected by human, by construction. So were the governments investing in this sort of facilities or constructions? So it's not so there was someone that made the cost of the corridors.
So that's I think something to look at. Like what we have here are these natural corridors, but absolutely, we can start to look at.
It's not affected by human intervention.
No. So these are natural corridors.
So they are all affected. So when you say water access, it's not the one determined by like aqueducts and stuff like that.
So it's
natural sources of water.
In fact, we eliminated all landscape modifications related to modern period like dams. We detected all dams and created an average cost without the dam. We didn't want to do this at a later because we want the model to be applicable anywhere at any period. All other modifications made by humans would affect very little up to the 19th century, in which you start like big roads and big tunnels and stuff. We have for the Roman period some canals and some investment in ports, but yes, we didn't include this in the base model, although we will include this when we talk, for example, about when we include the mobility in waterways, rivers, canals, and seas, and because of the boats.
Exactly.
But it's also because you want to see that it's a natural, low cost is what makes the cities be there instead of saying, I put the city there and then I make it low cost.
Exactly.
The causation would be different.
Yes, that's it. I mean, conceptually, you first have the city and then the modifications to increase the accessibility of the city. So what you want to check is this relationship. So yes.
At the moment, the model doesn't evaluate maritime routes.
No, at the moment, no. It will.
I have some early things about that thing.
No, at the moment, no. That's what he was saying. At the moment, we see differences in cities, still without adding the river and sea communication.
And the sea communication, obviously, in the Roman Empire is a big factor as well.
You have to avoid the flow of the sea or the tides.
He will explain it.
So it's wind mainly, but yes, we're going to add currents and the height of waves, and and that's obviously very seasonal compared to I'm showing here hopefully that even for the land, seasons makes a big difference, but for the sea, that's absolutely
So climate data at that era, that's something that is available and it's
well, not from that year necessarily, but like especially winds, they haven't changed in any way significantly, and we have data for every hour. I think going back to 1940, like every hour until yesterday, and it updates every day, like this wind data that we can draw on. So we can take all that data and average it to get an idea of wind patterns. And again, like that hasn't changed since the Roman period.
And the snow and all of that that you were using, how was that? How did you get that? That's also a proxy from now.
Yeah, I guess so. That's all modern data.
It's a proxy. We thought of using some kind of old models, but we are not that sure. And what is very interesting is that some things might have changed. For example, the elevation of deserts. Some deserts have expanded, but as we are talking about a network, this will affect very little the network. I mean, if instead of going this way, it has to go a few kilometers after in terms of a long route, it would not make much of a cost difference. Okay, so what we are interested is in
the cost.
Average patterns. For example, we have included things like not just cold but also heat, and we know there might have change the highest and lower temperature, but we know this difference in heat cold is going to be very, very similar. Okay, or other factors will not change that much. For example, one of the factors is the lack of oxygen above 2,000 meters. Okay, so this has not changed. The cost has changed, but in terms of how a ship would move, if there's a higher or a lower delta, it will not affect the total route of the coast whatsoever.
And
So,
we're
yeah.
and when we have all these uncertainties with like 2,000 years ago, those are very small.
Yeah, I mean, for sure in the future we can use models for past climate. There are some available, but the spatial resolution of these models is too low. I mean, too low as to be convenient.
Yeah.
And you're using this in the Roman Empire, but you could potentially use it for any time of civilization, right?
Yeah, absolutely. So I mean that again, that's why we're using these kind of natural data because that's available at all of them worldwide. And again, like me using these 40 node sites. If you have a smaller area, you don't need 40. I've done tests with I think 4 sites in the Roman Empire, and it gives some good routes. And the more you use, the kind of better. But even 3 or 4 sites, especially for a small area, you can yeah. And what I was saying at the start, we have these roads reconstructed for the Roman Empire that we can compare it to. But if you don't, we've not used that in the model. So if there's no roads, it's not a problem. It's the costs that are the main thing. So even if this route is slightly different, the cost between A and B should be accurate. So you can build this network. So yeah, so again, like this early approach, as I said, like the idea is to kind of build this network of costs. But using this kind of raster output that we have just now, we can compare individual sites across the empire. So again, we have like, an individual value for each season that we test for every single site. So the 1,500 sites, and you can, compare these. So again, like the closer to one, the lower the value, the closer it is to one of these low cost corridors. And so these are like the 5 lowest for the average across the year for August, the summer conditions, and February, the winter conditions. And you can see most of these are in Italy or in the east of the empire. So these kind of urban areas, they all seem to be, the sites that have the areas that have the lowest cost sites. But it's also quite interesting to look at the higher costs across them. And in this case, we have most of these are in Mauritania. So that's the northern coast of Africa. So you can see here, like it's these kind of sites that we're looking at. And again, this is, I think rather than it suggesting these sites were more disconnected or further away from routes, again, this is only the land. So I'll show you in a bit, like I've started to model the maritime corridors, and we have clear corridors every month basically going right past these sites. So maybe what this is showing is that these aren't that well connected naturally by land, but by the sea, they have these corridors. And also we see like a big switch between summer and winter. The sites change with the highest costs. Now these are all kind of mountainous sites. So this site in Dalmatia is in the Dinaric Alps in Croatia. And then the rest of these are all in Asia Minor, so modern Turkey, which you can see here. So again, this is the winter, and you see all of these sites. So they're the highest cost sites, so the furthest from a low cost corridor in the winter. But then if we look at August, you see how much that changes. We have these corridors that clearly go right through these sites. And again, these sites aren't node sites. They're not in the model at all, but they lie right on these corridors in the summer. In the winter, the furthest away. And again, this is highlands, so this is high up, cold with snow. So when we factor in those costs, it completely changes what we're looking at. So it's, again, like talking about modeling sea mobility, people have, looked at these patterns and how it changes seasonally. But for the land, people generally don't model that, but it clearly makes, a big difference with this one example. So yeah, and again, so this is like the seasonal changes. There's seasonal changes for every single site. Some of them are quite small, but then you can see there some of them are very big. And again, so like the difference between winter and summer is the biggest difference, obviously. And so we've only modeled August and February here, but that kind of, again, it's the extremes. So we see these differences. So yeah, that's the kind of data we have for this current paper looking at urbanism and seasonality. But I'll quickly talk about some future plans before kind of finishing up and if there's any questions. But again, one of the kind of main ideas with this methodology is to help us reconstruct routes. So we have these routes that have been reconstructed using archaeological data. And we have, quite good detail on a lot of them, especially like around Rome and Italy. We have a lot of evidence for that. But even with that, you can see there's gaps. So, there's some dead ends. There's a bunch of cities that aren't on the network at all. And that's the nature of, this data. It's inherently incomplete. But then using this method, we can start to connect them remotely and kind of automatically, without us having to draw lines. You can see, the dead end there, but already our corridors, you can see the route that goes again through all these cities and links them up. And you can see down here as well, and there's kind of a route here. And again, the exact direction or like exact route that these take in the model isn't the main important thing. It's the cost between them. So we can fill in the gaps in these networks and then have actual costs between every single site without having to have archaeological data for how did you get from A to B as well. We generate this and this is the cost from A to B. And if it says that's the route, maybe it took a slightly different one depending on whatever else, but that's the cost between the routes. And then using that, we can reconstruct, again, with 40 sites in this example, we can reconstruct the exact cost between any two of 1,500 sites. And again, that's, we can do that for anywhere that we have sites that we want to look at. And yeah, another example here. So this is, that was in Italy around Rome. And then we have in kind of Netherlands, the German provinces of the Roman Empire. And you can see a lot of dead ends and a lot of kind of straight lines here, where I have slightly different availability of data. And again, there's different availabilities of data depending on the country that they're found in the kind of scholarly history of that and how things are excavated. But with this, it's again, we're just drawing on natural data. So this will be universal across whatever area we're looking at. We have the same kind of results coming out for these corridors and to reconstruct this network. So, and also a little bit about the maritime stuff. So I've started reconstructing these. And again, as I kind of mentioned, these are based on wind patterns. But we're going to add things like the currents and the height of waves and also uncertainty. So how varied the wind patterns are and how that, increases risk and uncertainty of sailing. But again, you can see here, it's the exact same approach we have. We make the cost surface for the sea based on wind, and then we have select node sites and we generate corridors between them. The difference here is that it's the direction of travel makes a difference. So for the land, going from A to B is the same cost as B to A. But when you're sailing, obviously, if you're sailing against the wind, that's very different from sailing with the wind. So it's the same method, but we've added this directionality to it. And so this is in August. In February, again, you can see it changes. And I've done every month for these. But, there's differences in routes. And again, the costs all change month to month. And just some examples. So this is just all the routes to and from Ostia, so the port of Rome. And so it's the same, we've generated these cumulative cost surfaces from one site and then merged them together to get this overall thing. And this is like, we haven't put them together yet. These are two separate things currently, but we're kind of have some ideas of how to put these together based on costs and the kind of cost of transitioning from land to sea at ports. And again, depending on port infrastructure, that might change the cost. But that's kind of, the ultimate aim is to have these all together and then with the inland waterways, so the canals and the rivers, and have this kind of universal multimodal network. Not just this raster-based approach, but have the exact costs from any given point to any other given point. And you can do it over land, you can do it on land, get on a boat, and then go on a river or whatever else. Some ways in the future. But we have the core of that ready to go. And it's just a case of refining it and then putting it together with the costs. I think that's everything for me today. If there's any questions, I'm very happy to take any. Thank you.
Thank you. That's excellent presentation. If you could go back 2 or 3 slides. No, sorry. Yeah,
That's fine.
in these ones that you have the reconstruct routes,
Yeah.
right? The reconstruct routes that you find from archaeological site. So, do you have the time of when the routes were built?
Some,
Any time? Because
yeah.
I just wonder,
Mhm.
just looking at this, that if they were the ones that follow the earlier ones,
Yeah.
the ones with the low cost.
Yeah,
Because then once the cities are established,
exactly.
you might be
You start to get
building
different.
a route that it has some cost, but
Yeah,
it's
but you
lower
have
than
two sites here.
but you have to important urban.
Exactly. So I mean,
Yeah.
yeah, I mean that's something you can look at. You know, there might be, I don't know. Well, I mean, these clearly go through kind of higher costs,
Right,
but
that's why
we have a
it's
low cost corridor here and one here.
Yeah,
So then to
but
connect them,
earlier.
exactly. Yeah,
together.
yeah. No, and that's
But you don't
something.
have the data. for
No,
that.
not yet. I mean, some of these roads, especially around Rome, have like quite good dating for them. So it's something we can look at and
Okay.
see. And same with the cities. I mean, again, it's the nature of like archaeological data. Some sites have very good dating, some don't. But certainly if we look at some of these in Rome, around Rome is probably the best place to look at, and see when these roads or the cities pop up and then when the roads are put in. Yeah.
Can you also try and see places where we're probably missing some cities that
Yeah.
exist? So
No, absolutely. And I think that's something as well, you know, it's not just to find routes, but to, well, we don't have the cities there. But yeah, well, when you say as well, like these intersections, you know, to start, it can kind of help us with the remote sensing. So if we have clear like corridors and there's no cities on them, it's okay, maybe that's somewhere that's worth going and investigating on the ground. Because you know, a lot of like archaeology is like, well, where do you dig? And this is like another tool that can help with that. And maybe there is some sites along these routes. Yeah.
Do you have any kind of data on paths that were used before the Roman arrived? For example, to
Like routes, yeah, it depends. I mean, there's pastoral routes and things,
Mm.
and you know, a lot of these. Well, it depends where you are in the empire as well, because in the east, especially, a lot of these cities already exist, so there's already some routes.
And does this like improve the like to explore like the Roman roads?
Mhm. And improve the what, sorry?
The feet of the like the cost of the path.
Oh, like adding these, like-
variable, like the pathways that were used before the Roman came, you include it. Does this reduce the cost and this improve the feet?
Yeah. So I mean, again, that would be a different thing for us to look at. Again, we're
Yeah.
like trying to have here just kind of
Only natural.
yeah, exactly, entirely natural. But then it's something, you know, to build the network. If there is a road there at the time period you're looking for, then you can, again, the nature of these like cost surfaces being factors. So we have slope is the raw cost, and everything else multiplies the cost. So again, that's something we could add. If we know there's a road there, you could divide the cost. And you know, it's all just numbers. But I think for this current thing, looking at these broad trends, you want just the natural. But when you start to add this infrastructure, you can reduce costs rather than increasing costs and see how that affects, you know, movement along the infrastructure. Yeah.
Sorry, if I understood correctly, you said that sea corridors like are affected by the wind, so going from A to B is not the same as going
Yeah.
from B to B, not B to A, but but in land, you are assuming that A to B is difficult.
Yeah. So I mean, so for going like up a steep slope or down a steep slope, it changes. But when you're the best slope is a flat slope, you know, no slope. And whether you're going down or up. And now that so for combining them, we will have to have the land be directional as well. Because if one part of it's directional, it all has to be. So that's why these are separate just now. So that's something we can add in. But and again, it's, you know, the seasonal changes for the land are less than the seasonal changes for the sea, and same with the directionality. But we might see when we add the direction that it does make a significant difference. But yeah, we'll have to add that in, but it's certainly compared to
Let's see, the movement in land does not have a difference in directionality by season. That is, if you go from this city to this city, the cost is going to be the same if you go this way than if you go this way. Okay, and this cost is going to be higher or lower depending on the season, but the directionality of the cost is going to be the same.
Yeah.
Okay. However, in sea, You know, if you go this way
Yeah.
or this way, it's going to change according to season.
But also
Yeah,
what they're saying
the slope.
thing.
Yeah, so
Yes.
you're assuming that going up is. the
Yes,
same
because
cost
what we
as
are
going down.
interested is how much it costs between to move between two cities.
Mhm.
And if you go this way, you know, if this city is low, this city is high, you know,
Yeah.
it's going to cost much less to go down.
Yeah,
You know, but they are going to have a cost that is unique, no matter, you know, if you go up or down. Because what you want to know is how much it costs to go between the cities. So sometimes it will be lower, sometimes it will be higher, but the average are going to be the same.
But if there's one way down and then one way around that is slightly longer, then it's so
Yes,
why
the analysis will consider this a much lower cost.
Yeah.
So, but I agree that it does, you know, why the wind aspect, you don't really take the average of going up, back and forth.
Because it's seasonal.
this changes,
Uh-huh.
It changes
it changes
according,
in often, like,
no, because it changes according to time,
Well, it's-
not according to physical characteristics. Okay, because you are not interested in knowing how much it is to go from this city to this city. You are interested to know what is the communication, how is the cost of these two cities, and you know, with time, this cost will change because there might be snow, but the cost is going to be the same during the same season. You know, because sometimes it will be low because you are going down there. So sometimes it will be high, but the average, you know, the communication between the cities will have an average cost. You know, that's how much it costs to go from one place to another. However, if you do it by, you know, this extra dimension, which is time, will affect the sea and the land, changing the average costs, you know, between places in general. You know what I mean? We are not interested in a direction of movement, but the communication capability. But in the case of sea, this is affected by season, so you have to hold this.
Yeah.
Okay.
Yeah. And I think as well, like the cost of, you know, going up or down a slope, it's flat again is like the best. Where if it's, you know, you're going down a slope, it's more costly than flat, even if it's the same slope. But where like
If
the
you're
sea,
going with a car,
yeah,
it's much more problematic to go downstairs.
yeah.
Yeah.
And when it gets to a certain slope, like going down is
Yeah.
where the wind is like a kind of almost 1-to-1. If you're going with the wind, it's good. If you're going against the wind, it's bad. It's yeah, and no wind is also bad. Where no slope is good. So there, yeah. And again, like when we combine these, we will have slope in there, and it might make a bigger difference than I'm
At
expecting.
some
But
point, this will become an enemy.
Yeah.
And it's with Andrew and me, we have developed different ways to create out of this vector network. So you can use you can put directionality into the network according to the slope. We are not at this stage, but this is something we can do. You know, and another thing it will be taken into account that is what James is working on. It's on the type of transport and how much it takes to change the transport. It's not the same to go by mule or in a cart or in a ship, or which type of ship or through the river. Rivers are very clear cases in which you need directionality. If you go up river, it's going to be costly. If you go down river, it's going to cost much less. So this thick directionality will be added during the network when we have created a network out of it, which is when we'll be able to do other types of analysis. Just I guess the real thing in terms of our laboratory and research group is that, you know, in the past, communication was physical. There were no emails, there were no, you know, I mean, you could always throw an arrow to somebody with a written message or a stone, but, you know, I mean, that's as far as you would go. You know, and you need to move to have any kind of communication. So in order to study any interaction, that is the transmission of ideas, viruses, people, migrations, world relations, you know, the transmission of culture, literature, you need a model that is able to analyze this in space and time. Okay, and this doesn't exist. You know, there's no way you can analyze this because in some cases you have very fragmentary information. For 99% of the history of humanity, this information is the location of towns or archaeological sites. That's what you know. So how from this, how do you create a method that is able to analyze things like that? And this is the idea. With very fragmentary information, the position of human settlements, you can extract a network that you can analyze, you can use for the analysis of communication in the wider sense. That was the idea. Is trying it with the Roman Empire because we have lots of data. One of the data that we are more interested is actually the actual location of roads. And that's, I think, one of the conclusions, the better conclusions of this study. I don't know, Andrew, let's go ahead and explain this because I think it's, because we have created this and it looks weird. I mean, it's like colors, I mean, I can see this as a vector network. I see how it's going to be transformed, but it's a bit weird. But one of the really interesting things is that we don't want to recreate the roads. We want to recreate the network using the cost, how much it costs to move from here to here in this moment with this in this way.
Yeah.
Okay, so physically, this doesn't. What we have created is a graph, a theoretical graph in which every edge is a cost. It's a series of costs according to the circumstances. So the really interesting thing that Andrew was able to test statistically is when you take the actual roads, the roads we know it existed, and you analyze the actual cost, it's very, very, very similar to the simulated cost. That means this is, that's why we try the Roman Empire, because we have lots of cities. Instead of using the 1,500 cities, which is something we could do. I mean, perhaps when we implement Apache's
I've done it like on a smaller scale, but
at the moment we are using like a DCPU course and they're still taking some, because I mean, you have to analyze the methodology goes from city A to city B, from city A to city C, from city A to city D, and then when you have them all, you go from city B to city B. Yeah. So basically, the 40 cities implies hundreds and hundreds of analysis that we try to perform in different cores of the same to parallelize because it would be eternal otherwise. But you can do this with all of them and get a completely useful map of the Roman.
So that was very interesting. Thank you very much. Have you considered adding information from desktop sources as well? Like, like that there are projects that georeference places mentioned in the source, and actually there's a lot of people working in the classical domain. So I was wondering.
Yeah. So I think a lot of these roads are not just archaeological data, but these literary sources of these are the routes between them, and as well the costs of how long it takes.
Information from sources saying
Yeah. No, exactly. So you get the costs between them, and there are examples of that, and for sailing as well. But then they never give the kind of detail that you need. So at least for sailing, those are the ones I know better. You have a lot of routes that they took. I sailed from here to there, and it took 9 days. But they don't tell you what the conditions were like. Was that a fast sailing? Was that a good sailing? And it helps and to try and reconstruct these. And it gives you a base to, I think, compare the outputs with. But I think trying to build that in, it kind of limits the applicability of it. But certainly to test it. Yeah.
Goods or do they
James has been working, and that's mostly James has been going to all sources to check the location of roads, the distances, how much it costs, how much time you need to pass from one transport mode to the other. So yes, James is kind of giving us the data, and our models we never rely with the data because it's very variable. But we try to see with our models in which conditions this to try to join them both to get a very reasonable image.
Yeah, well, exactly. If you have that journey that you said it took 9 days or whatever, and then you check the model and see when does it take 9 days, then you can work out if that's good or bad conditions.
Right?
Yeah.
And so you understand the point. This is so what you get here is the likeliness of the real routes were to happen.
Yeah, so it's probabilistic basically. Yeah.
Yeah, we have used ethnographic models of how much cost for a healthy used to walk, ethnographic models of how much it costs under different circumstances, upslope, how much it costs to breathe, how much. So there's an extensive, well, not that extensive, it should be more extensive, but there's literature on it. We have, in many cases, we have created our own mathematical models to reflect the field data we have. For example, how much it costs to breathe at different heights, for a person that is not living up there and it's adaptive to this kind of. So
Yeah, the physical variations of
Yeah.
the person.
yes, somebody from Peru would be much better adapted to this, but somebody that's traveling long distances.
I'll say I've like tested very small scale, like some walks I've done for like 3-4 hours, and it like the time like this model put out was the time it took me. So it worked.
Something I'm not sure I understand. So
Mhm.
if this is like it's on what time? So there's not the time variable for some.
For you mean like
Yeah,
period
example,
or
yeah, no, like within a period.
uh-huh.
So for example, you're going through the life event when
okay.
it evolves and changes.
Under these conditions. Yeah, exactly. So we use like average conditions. So this is August, and it's the average conditions. So what you would expect to be kind of normal conditions in August. So obviously those extremes that will change it. But
then what you don't see right now, what you cannot apply right now is like, for example, there is an evolution of roots which don't have to respond necessarily to climate conditions. They can respond
exactly.
to political mobility restrictions and fire changes.
Exactly.
I don't know.
No, absolutely. And I think the benefit of this all basically just being numbers and like factors. So again, like if we have these other costs that we want to add on, we can say there's a border and add a cost there. Or again, when I'm looking at moving from land to sea, there's going to be like, a huge cost for doing that unless there's a port. And then there'll be, based on James's work, we'll have another factor that adds a cost to go from land to sea. So this is the kind of core base model. And then we're starting to build on with exactly those kind of things.
So in terms of communications and network, for example, I am more on a modern period, so I'm gonna go all the way to the 19th century. For example, if you could not travel from Barcelona, when you put the maritime data as well, but it's not only the conditions, it's also that I can actually politically, legally take a boat and go to America.
For sure.
Yeah, this is not for earlier periods. Let's say, when we start having, for example, steam that makes wind a bit less relevant. Well, that model doesn't work anymore. But it's always the period of the data you put in. For example, as an historian or an archaeologist, you are going to what are the basic cities, the one that existed before, the ones that created the network, and then you can get this network and select data of later cities and see how the network changes and evolves. It's, as you see, the colors are the probabilities. It's a probabilistic network. It's an exploratory model. That's why we didn't transform it in vectors, because you don't want to say, okay, this is the row. I'm not interested in this. I want to explore it statistically. And when I get a network, it's going to be an analytical network, and I don't mind if the roads are straight between points, because I want to see the cost of movement. So, it's a model that is thought to explore with field data what is the importance of communication, mobility, connections, in different cultural, social aspects. So it's we try to it's one, in terms of our group and our laboratory, is one of these things that we would like at some point to be a general tool for the study of social, human, cultural relations. Any relation that implies contact, communication,
And even
in the
maybe
past.
immigration.
Immigration,
absolutely.
mobility. I developed this model for things like for transcontinental routes. I studied the first application with the sea routes, which I have listed as partners. But also the human expansion from Africa, the different groups, you know, how would they have moved, including several modifications to the lands, you know, so it can be, and it's amazing because when you start studying things like past human mobility, you realize that it's so much more important than assumed.
Yeah.
Really, you know, I mean, really,
I think you think of it as like a barrier, but it's
so
the highways.
this kind of modeling that, you know, I mean, because in archaeology and in many other disciplines, there's a big criticism against models that include more than 2-3 factors, you know, social modeling, you know, because it's like it's too complex, you cannot know. But the good thing about this is that it is based on real cost, physical costs that have been very well studied, and the every one of these factors improve the model, and we have been very conservative with the values. You know, I mean, for loose sand, we didn't. There are like 20 studies of how people would move through loose sand, but we didn't got the more extreme. You know, so it has at the moment, I think it's 15 different factors, all of them carefully balanced. And I think it improves enormously over any other previous analysis of this time. So it's there. I don't think it's going to take much more months because we have already transformed it in vectors, and we are just discussing more theoretical factors and trying to validate factors. It's a good moment for this seminar. But hopefully in 1 year this will be in our metaverse, in our repositories, and you know, with all Jupyter notebooks, with associated data sets for testing, and hopefully it will be one of the third tool we get out in our lab, no? After Mariana's, you look surprised. And you know, and the seeds shape analysis.
It's more from the sort of modern.
I'm
modern
sorry
period.
that I need to.
No problem.
It seems like
Very nice.
Yes. Yes, I mean, the more the technical development advances, there is natural factors of movement. I mean, today we have planes, so it's kind of, you know, straight lines. Kind of, yes. This, of course, for this kind of factors, today you have something like, I mean, it's less conceptual, but you have Google Maps, you know, and this is something you can use this just as a Google Maps of the past, because you can create the models on. But yes, this modern movement is not that difficult to model. You know, you can do it, but because all ships, for example, have transponders, so you know all the routes. You can all airplanes have you know, you can model, but if we were to put this together with our model, it would be very, very complex. The really difficult thing to model, it's things like the 19th century, in which you still have you already have trains, but you know, I mean, the first train in Spain, no, from Barcelona to Mataró. You were eating in Barcelona and you were having dinner in Mataró, and that was considered a wonder. When I went to it's like, my God, where were they going? You know, so for this period in which transport means we're changing so much due to technical advances, it's very complex because you almost need a model for every 10 years or so, you know, so that's yes, that's something we will probably not be modeling anytime soon.
I think that's another thing. Like the Roman Empire was a good case study as well, because not only is it kind of, you know, there's a solid period where it is this kind of unitary state. So, you know, there's provincial borders, but and the technology broadly the same for all of it.
Yeah. They are to the 17th century with the same technology. Yeah.
But it would be interesting to see if that creation of nodes of cities, of intersections, of network does influence in the future the routes, even though those are much more altered by human-made actions and maybe overrule seasonal, but maybe the base is that it's more seasonal.
I think it has to be because, like, if urban centers, are reliant on these natural routes, then the routes we're going between even today are between, oftentimes, well, in Europe at least, urban centers that have their origin in the Roman period or earlier. So
You would
it's
be very surprised
Exactly.
if you were to compare the Roman road network to the modern network. They are extremely
Yeah.
similar. And the thing is that one of the things he was commenting is it may be some cities that are very well communicated. They form nucleus of communication. These cities have perhaps they are bigger or smaller, but those what I want to check in detail in the future with Andrew is how much they last in time.
Yeah.
Because I'm completely sure that connection during the Roman period meant the city lasting and overcoming all periods. And it's you have all the big, Barcelona, it's a Roman city, Rome, of course, Paris, London. London, it's an excellent example of how the relative position in the Roman road network preserved the city during the last 2000 years. So what we are seeing here with this specific example, not with the communication methodology, in fact, it's the origin of the distribution of people in Europe today and how people move in Europe until very recently. And that's very little doubt of this. I think, that's a very interesting paper.
Yeah.
Could the model predict the opposite, a high cost?
Yes.
Okay.
Yes,
Because
you only see these lines, but
Yeah.
we could make them much thinner, or we could make, it's all this is a surface of possibility.
I was thinking in cities with a station with a high cost because I was thinking city
that were
region
mining
can
cities.
late. So
Yeah.
and you can explain why.
Yes.
This is a political decision, the war,
Or a specific resource they were exploiting. Yes. Yes. Yes, the resources also influence a lot, but if you are interested in this, it's very easy to modify the model, including specific cities you want to test or specific places. So it's kind of
Yeah, and as far as I know, at least in economic history, like the Roman roads are used as a basis till the 18th, 19th century, until we have the Bourbones, and then they start to decide to go to certain nodes stay.
Yeah.
Before that, it is typically used as an instrument for all kind of regulations.
Yes.
I'm working on something with that, and we use like the Roman road as the basis.
Yes, no, the national network of roads, for example, the route, the Mediterranean, the European route, that was the Via Augusta stuff. It's very well documented, and when they did the 19th century road network, the Scandinavian stuff, you could see all the churches, the center of the villages are in one position, and 200 or 150 meters to the interior, you have the national road because they couldn't build it in the middle of the villages because they will destroy. So the new roads are usually very much related to the Roman roads.
Except if you take Madrid, like random decisions of those house bills, they decide randomly where there was nothing with something like that.
Yes. No, but it was a very strategic decision, very political. I mean,
like when political and is going in place, it's not even commercial relationships because before when you look into the maritime, there will be a lot to Mesopotamia. But now
in this case, this tool is very good for this kind of analysis because what you took is the newly created cities during the Austrians or the Bourbon period and the old cities, and you compare the resulting network. You would see a radial network that didn't exist before. And this will give you we have been working with dots, position of cities, but these few cities can create a network, and then you can create another network and then compare the networks. So for this case, how it affected mobility the new modern empires. That's a very good one to do.
Well, it's really easy to just add one extra site. You don't have to run the whole thing again. You just every extra site you want to add, you run it once for that site, and then you just merge it as before. So if you want to add like a city like Madrid or something, and see how that changes the net.
So thank you very much.
Thank you all.